Now for a quick bit of revision before we go on. If a ray of light is headed towards you, the electric field vector must be in the plane that is at right angles to the direction of towards you, but it can point anywhere in that plane. If we look at the picture on the right-hand side, all of those blue arrows could show the direction of the electric field of all of the different photons of light coming towards us. Now, the quick way to show it is simply, rather than all of those arrows, using two perpendicular arrows of equal length. So that is what we use to indicate randomly polarized, otherwise known as unpolarized light. Now imagine we put a polarizing sheet in the path of the unpolarized light ray. The light that gets through is vertically polarized. But because all of the horizontally polarized part has been absorbed, the intensity of the polarized light has dropped to 1/2. This is called the 1/2 rule for unpolarized light meeting a polarizer. Let's further imagine that our polarized light now reaches another polarizing sheet. The amplitude of the electric field component that will get through depends on the angle between the two polarizers. Let's say that we have a vertical polarizer, but light coming in to hit it has electric field E that can be in any direction, and so the angle of the electric field to the polarizer is what we will call theta. Now only the component parallel to the polarizer direction gets through. In the diagram, that is the component EY. So if E is vertical to begin with, and that means it's parallel to the polarizer, then theta is 0, and all of the electric field gets through. So we always assume that these are ideal polarizers that don't absorb any light parallel to their transmission axis. On the other hand, if the electric field E was at right angles to the polarizer, theta is 90 degrees, and so the component that will get through is 0. Malus's law describes the intensity that you get after light has passed through two polarizers. So we start with unpolarized light. Then the first polarizer turns it into polarized light of amplitude E and intensity I0. Then a second polarizer is inserted. We call that one the analyzer. The angle between the two is theta. The amplitude of the electric field reaching the photocell will be E cos theta. And so the intensity, which is proportional to E squared, will be given by I equals I0 cos squared theta.